Alright, today we are starting with section 6.4. Now in this section we are going to talk about adding and subtracting rational expressions. Now if you guys remember in section 6.3 we talked about how to find the least common denominator, and then we saw some examples where we were given a certain denominator and we were trying to make our original denominator look like the new denominator. So you want to use all those concepts that you learned in 6.3 to help you add and subtract rational expressions in 6.4. So let's go ahead and see how you need to add two rational expressions. Now your basic definition here is you start with two rational expressions. Let's say P over Q and R over Q. As you can see, both of these have the same denominator Q, and Q cannot equal 0. So when you have these two expressions and you add them together, you will end up with P over Q plus R over Q. That will add up where you add only the numerators because your denominator is already common. Okay, since you have the same denominator, all you will do is add the two numerators and you will come up with your final answer. So let's go ahead and start our addition here with just some basic examples. Okay, so we'll start by adding rational expressions that have the same denominator, and let's say we have this example here: a over a plus b over a plus b. Okay, now just like our definition said, when you have the same denominator, all you have to do is add the two numerators and keep the same denominator. So here we will go ahead and add our numerators, which will give us a plus b, and you will keep your common denominator, which is the same a plus b. Okay, so you can see when you add your numerators together, you end up with a plus b over a plus b, and you have to write your answer in lowest terms. So when you add these two together and put it in lowest terms, you will actually end up with 1 over 1, because a plus b and a plus b will cancel out, and that leaves you with just 1 as your answer in lowest terms. Alright, let's look at another example here. Again, you will see this example has the same denominator for both rational expressions. So we will go ahead and start by adding our numerators. Okay, so again, just add the two numerators together and keep your common denominator, r minus 5. Now you want to try and put this in lowest terms. So again, remember, when you're trying to work with rational expressions of this form, you will have to first factor your numerator before you can start reducing it. So let's go ahead and factor our r squared minus 8r plus 15, and this will factor out into, let's see, r and r for your first terms, and then factors of 15 that give you negative 8 will be negative 3 and negative 5. So factor your numerator, we still keep our same denominator, and once you start reducing it, you will see that the r minus 5 cancels out, and in lowest terms this addition will be r minus 3. Okay, and there you have it. That will be the solution to our second problem here. Now when you're working with same denominators, it's fairly easy. All you do is add the numerators and then reduce it and put it in lowest terms. When you are working with rational expressions that have different denominators, it's going to be a little bit different. So let's see how you can add rational expressions that have different denominators. The first thing would be to find your least common denominator. That's your first step. Then the second step would be to rewrite each rational expression as an equivalent rational expression with the LCD as a denominator. If you remember, this is what we had done at the end of section 6.3. So that's the same thing you're doing here in step 2. Write the rational expressions as equivalent expressions with your LCD as the new denominator. For step 3, once you have the same denominator on your rational expressions, you can go ahead and add the numerators, and you will get the sum of those numerators. And this time, for this sum, what you have in step 3, you will use the LCD as the denominator of the sum. Okay, so you still keep the LCD as your denominator, and step 4, of course, would be again put it in lowest terms using the fundamental property of rational expressions. Okay, so let's try and apply these steps to our first example here. Now your example is 3 over 2x plus 4 over 7x. Now the first thing would be find your least common denominator. So if you remember, for your least common denominator, you have to go ahead and list all the factors from each of your denominators, and you can see that you have 2x and 7x. If we go ahead and break these down into prime factors, this will give you 2 times x, and this one will give you 7 times x. You list all your denominators, you know, how many ever times they appear. So 2 appears once, 7 appears once, and for each of the denominators, x appears only once in each of the 2 denominators. So you go ahead and list all your factors, and you will see that your LCD is going to be 14 times x, or 14x. So this is what we are going to use for our common denominator. Now that means I need to change my 3 over 2x and 4 over 7x so that both my denominators will now be 14 over x. Okay, so let's see how we can do that. Alrighty, so first thing, rewrite each expression as an equivalent rational expression. So you take 3 over 2x, and you want it to have the denominator of 14x. You will do the same thing with 4 over 7x. You want that also to have a denominator of 14x. Okay, so if I take 2x and multiply 2 into 7, that will give me 14x. So I need to multiply my numerator also by that same number, and 7 times 3 will give you 21. Okay, so now you can see that we have taken 3 over 2x and converted that into 21 over 14x, which is its equivalent form. Do the same thing for 4 over 7x. Now 7x times 2 will give us 14x. So that means I multiply my numerator also by 2, and 4 2s are 8. So 4 over 7x will be 8 over 14x. And now we can go ahead and add these 2 rational expressions now. So for our next step, we will take, you know, this was our original problem. We made these into equivalent expression, so that gave us 21 over 14x and 8 over 14x. Putting all of these together will give us 21 plus 8 over your common denominator, which is 14x. And what does that give us? 21 plus 8, of course, is 29. And of course you keep your common denominator as 14x. And now you can try and see if you can reduce this any further, and between 29 and 14 there's nothing common, so this will be your answer in lowest terms, 29 over 14x, and that's what we were looking for. Okay, so this is how you basically work with rational expressions that have different denominators. The first thing you do is start out by finding the least common denominator. Then, using your least common denominator, you try and rewrite your rational expressions such that their new denominator will be the LCD, and then you can go ahead and add the two equivalent fractions or equivalent rational expressions to come up with the sum of your expressions here.